Subtopic 6.3 Partial fractions. Two or more proper fractions can be combined to give a single fraction. Equally, a single proper fraction can be expressed as a sum or difference of two or more algebraic fractions. 1/3 and 2/5 are known as partial fractions of 11/15. Same goes to this example. 3/x and 2/x minus 2 are known as partial fractions. Definition: a fraction can be expressed or decomposed as the sum of two or more separate proper fractions. This is known as partial fractions. We have two types of fraction: proper fraction and improper fraction. A fraction is a proper fraction when the degree of the numerator is less than the degree of the denominator. A fraction is an improper fraction when the degree of the numerator is greater than or equal to the degree of the denominator. There are three types of the denominator for proper fractions. Type 1, denominator with distinct linear factors. Type 2, denominator with repeated linear factors. And type 3, denominator with quadratic factors that cannot be factorized. Type 1, denominator with distinct linear factors. Example 1. Express this proper fraction in partial fractions. By looking at the denominator, here we have two distinct linear factors. We can write this as x plus 1 plus with 3x plus 2. Linear factor at the denominator will have a constant numerator. So the numerator will be a and b. Next step is to equate the denominator. So here will be x plus 1 and 3x plus 2. You can use your pencil. X plus 1, 3x plus 2, x plus 1, 3x plus 2. Now you already have x plus 1 here, therefore a will be multiplied to 3x plus 2. As for b, you already have 3x plus 2 over here, so b will be multiplied to x plus 1. Since the denominators on both sides are equal, it follows that the two numerators must be equivalent to each other. We can use this to find the values for a and b. There are two methods that we can use to find the values for a and b. The first method is by substituting at appropriate values of x. The second method is by comparing the coefficients of corresponding terms. By looking at this equation, we can choose x to be -2/3 and -1. When x equals to -1, we have and this term will be 0. So we have a is equal to 5. To find b, you can either use x equals to -2/3 or any value of x that you want to use. Why? Because you only left with one more constant. So here, instead of using x equals to -2/3, I am going to use x equals to 0. So b is equals to -13. Hence, this is the partial fractions. Second method. Find the values for a and b by comparing the coefficients of corresponding terms. So first, we need to expand the equation. Now we are going to compare coefficient of x. The coefficient for x at the left hand side is 2, while the coefficient for x at the right hand side is 3a plus b. So this will be our first equation. Next, we are going to compare the constant. The left hand side is -3 and the right hand side is 2a plus b. This will be our second equation. So now we have two equations, two unknowns. So we get a equals to 5 and b equals to -13. Hence, This is the partial fractions. Tips. It is easier for you to use the first method to find the values of the constant if you have the denominator with distinct linear factors. As for the second method, if you wrongly expand your equation, you are not going to get the correct values for the constants. Example 2. Express this proper fraction in partial fractions. By looking at the denominator, we have three distinct linear factors. We can write this as x plus 1 and 2x minus 1. As we have three distinct linear factors, so the numerator will be a constant a constant b, and a constant c. Next step is to equate the denominator. Remember to use your pencil. Now you already have x here, so a will be multiplied to x plus 1 and 2x minus 1. You already have x plus 1 here, so b will be multiplied to x and 2x minus 1. You already have 2x minus 1, so c will be multiplied to x and x plus 1. Now you can use the two numerators to find the values for a, b, and c. I am going to use the first method. The x values that I can use: x equal to 0, x equal to -1, and x equals to 1 over 2. Again, I get the x values from the factors given. When x equals to 0, 5 times 0 plus 1 is equals to a. 0 plus 1 times with 2, 0 minus 1 plus with b times 0, so 0 plus with c times 0, this will be 0. So a is equals to -1. When x equals to -1, b is equals to -4 over 3. When x equals to 1 over 2, c is equals to 14 over 3. Hence, this is the partial fractions. Type 2. Denominator with repeated linear factors. Example A. At the denominator, we can see that we have a linear factor and a repeated linear factor. X plus 5, the whole thing square, is called a repeated linear factor because the linear factor x plus 5 is repeated 2 times. Therefore, x plus 5, the whole thing square, is called the repeated linear factor. So, for the partial fractions, we can write x minus 3 plus x plus 5 and x plus 5, the whole thing square. For example, say that we have a denominator with x plus 1 power 3. So, it will be x plus 1 power 1 plus with x plus 1 power 2 plus with x plus 1 power 3. Now, we go back to our example. If we have a linear factor or a repeated linear factor at the denominator, then the numerator will be a constant. So we have a constant a, a constant b, and a constant c. Okay, now look at example b. At the denominator, we have x squared and 3x plus 5. X squared is a repeated linear factor and 3x plus 5 is a linear factor. X squared is called a repeated linear factor because x is repeated 2 times. Therefore, x squared is a repeated linear factor. So, for the partial fraction, we have x squared, and 3x plus 5. Say that we have a denominator of x cubed. then the partial fraction will be x plus with x squared plus with x cubed. Now we go back to our example. So if we have a linear factor or a repeated linear factor, the numerator will be a constant. So here the constant will be a, b and c. Example 3. Express this proper fraction in partial fractions. So by looking at the denominator, we have a repeated linear factor. We call x plus 2 the whole thing square as a repeated linear factor because the linear factor x plus 2 is repeated 2 times. For the partial fractions, we write x plus 2 and x plus 2 the whole thing square. If we have a linear factor or a repeated linear factor, then the numerator will be a constant. Therefore, this will be a constant a and constant b. Next step is to equate the denominator. Make sure you have the same denominator from the question. Now you can use your pencil. So x plus 2 the whole thing square and x plus 2 the whole thing square. You have x plus 2 here. Therefore, x plus 2 square divided by x plus 2 is x plus 2. So you end up with a times with x plus 2. As for b, you already have x plus 2 here and x plus 2. So you will have here just a constant b. Now you can use the two numerators to find the values for a and b. I have two constants here, a and b, so I have to choose two values of x. So first, I am going to use x equals to negative 2. And for the other value, you can use any value of x. So I choose x equal to 0. When x equals to negative 2, b is equal to negative 14. When x is equal to 0, a is equal to 7. This is the partial fractions. Example 4. Express this proper fraction in partial fractions. By looking at the denominator, so we have here a repeated linear factor and a linear factor. Therefore, the partial fractions will be x, x squared, and x plus 2. If the denominator has a linear factor or a repeated linear factor, then the numerator will be a constant. So this will be a constant a, constant b, and constant c. Next step is to equate the denominator. Make sure you use the same denominator in the question. You can use your pencil. X squared x plus 2, x squared x plus 2, and x squared x plus 2. You already have x here, so x squared x plus 2 divided by x is x plus 2. So a will have x and x plus 2. b already have x squared here, so x squared. b will be multiplied with x plus 2. And for c, you already have x plus 2 here, so c will be multiplied to x squared. So now you can use the numerator to find the values for a, b, and c. So now you have three constants a, b, and c. So you have to choose three x values. So the first value is 0, The second value is negative 2, and you can use any value for the third x. I'm going to choose x equal to 1. When x equal to 0, b is equal to 1 over 2. When x equals to negative 2, c is equal to negative 3 over 4. And when x equal to 1, a is equal to 3 over 4. This is the partial fractions.